Hi guys, welcome to today's learning session. Today I'm here to discuss about a organic name reaction which is very important. The scientist Charles Woolf had given this reaction in 1872. So first we'll understand what is the condensation reaction. The term condensation are the reaction where two molecules combine with each other with the loss of a small molecule, usually water. But in this case, in Aldol condensation reaction is the coupling of an enolate ion with a carbonyl group compound to form a beta hydroxycarbonyl and sometimes followed by the dehydration to give a conjugated enone. In simple word, if you'll understand, two ketone combine with the loss of water, this reaction is called an Aldol condensation reaction. So we'll come to the synthetic part where this is the enolate compound where coming with the another acetone compound. Here we are taking acetone in presence of base is giving us this is the aldol compound, which in further step by dehydration we are giving certain temperature. In that temperature this is giving us enone compound. So the overall mechanism for this aldol condensation reaction will explain by two methods. Basically, one is the base catalyzed aldol reaction, another is the acid catalyzed aldol reaction. This base catalyzed aldol reaction may give the aldol product, but that mechanism followed by the unimolecular U1CB. That means unimolecular conjugated base elimination reaction, but the acid catalyzed aldol reaction which follow the U1 reaction. That means unimolecular elimination reaction. So these two method, how this mechanism is happening, we'll understand now. First I'll come to the base catalyzed. First we are taking this enolate. R group is connected to this carbon like this. This is the structure of enolate. So when a base group is coming, this base will attack to this hydrogen, so this bond will migrate, and by deprotonation process, this will give us a enolate. By migration of this hydrogen, it will form one double bond here and here, O minus and R dash. This is the enolate. Further, this enolate will condense with another carbonyl group, that acetone we had taken. This is the R3. So by migration of this ion, and this bond will come to the here, and condensation will take place, will give us another form of compound. So this is the compound. So this one will go to the next step by acidic workup. This compound will give us corresponding aldol product. This position will form one OH group. How we have written before, similarly entire things also will write. Only this O minus by taking one H is forming. Why this is forming beta hydroxy? See here, this is the with respect to this carbonyl group, this is the alpha position, and this position is the carbon is the beta position. So because of that, this is the beta hydroxy group is forming. So this is the aldol product. So with this regard, we'll come to a simple another example where we'll take lactone. Another example, lactone group we are taking. So this lactone group, here is a hydrogen is present, so this base will go and attack this hydrogen, and it will give, this will give us enolate ion. This is the enolate ion. So this enolate ion again will condense with the another lactone, which will give us so this will go under by hydrolysis. So this oxygen, the ion is present on oxygen, will get H, will give us aldol product. So this is the aldol product. This is nothing different, very similar. How fast, this is two different kind of example we are just taking, not very much difficult. So first we are taking enolate, in second case we took one more example, that is a lactone. Similar way, here also we are explaining for your better understanding. So here in the aldol product, before this hydrolysis we are seeing that next to this carbon one oxygen was there. So here also by hydrolysis, after hydrolysis, next to this carbon oxygen is present, and this O minus is forming OH. Then again it will go to the next step by OH minus. From alcohol, by water elimination doesn't happen normally in alcohol in basic solution, but because of there is carbonyl group is present, so this elimination is taking place. So OH minus will attack and will give us OH minus. How it will attack? Here is the hydrogen is present, this OH minus will attack and will take this hydrogen, by elimination of water is going out. So here is forming the, by after taking this hydrogen, here is the bond is forming and this bond will migrate towards this side. In such way, here is the ion is forming. So again in the final step, this one will come, this bond will come to this side and elimination of minus OH. So it will give us enone compound. So this is our required, here will form the bond, double bond. So this is our enone compound. So one thing we learned, by aldol condensation reaction we will get two types of product. First we are getting the aldol product, this is the aldol product, In second step, by dehydration happening by water loss, so we are getting enone compound. So in similar way, this is we saw base catalyzed. We will come to the acid catalyzed, how it is happening. In acid catalyzed also there is forming of aldol product, but mostly it is forming enone compound, but the mechanism followed by the unimolecular elimination reaction. So we'll see the mechanism. In similar way, how we have taken for basic catalyzed, we will take enolate. So hydrogen is present. By acid catalyzed, it will attack to here and will form OH. Because of extra valency, one positive charge will come on oxygen atom. So then again it will give us enol. This bond will migrate towards this side. Because of this is not stable, so this bond will migrate towards this side and will come to this side, and here we will get one double bond, one OH group and RDS. So this is the enol. So this enol, in similar way, it will condense with the another carbonyl group, because according to the definition we will take two carbonyl group. So enolate we have already taken, so another we are taking acid catalyzed, this acetone group we are taken, so that one is coming and condensing with this enol group and giving us the, how it is coming. This one we can write like this, O bond H. So this bond will come to this side and this bond come to this side. In this manner it will come and it will give us corresponding aldol product. So this is the aldol product. See, similarly it is nothing different. This bond is, this R group is connecting to this carbon, so this carbon is having one OH, R3 and R4. Elimination of hydrogen, it is giving us one ketone group. So in this also, how I told you, we will get enone compound. How we are getting, we will see. So again one H plus will attack, so this one will attack to this OH and will form OH2. So here one positive charge will come, other thing will write same. Again this OH2 will go out as a water. When it will go out, here one positive charge will come, because of carbon mostly carry 4 valency, so one positive charge will come here, R group are there, ketone group will write R1. Then here in carbon one hydrogen is present, this one will, to fulfill this valence of carbon, it will come to here, so that by elimination of one hydrogen we will get R3, R4, see the RDS. So here we will get double bond and R. So this is our enone compound. This is our enone compound. So this is the entire mechanism for our aldol condensation reaction. Other than this, From the exam point of view, we'll discuss some more example which will help students for understanding this concept more. When, because in exam questions comes in this way, it will give reactant and some of the reagent. There we have to find the product. If we'll practice more on this, more example we'll practice, then in that exam time we can identify at least this is the coming from Aldol condensation reaction, and we can answer. Mostly NET or GATE exam, other exam also this kind of questions come. So for that only I'm discussing here to some more example. Here we are seeing in the reactant side one carbonyl group is present. So this carbonyl group in presence of LDA, lithium diisopropyl amide, and tetrahydrofuran. These are the base. This LDA is the strong base involving MgBr2, magnesium bromide, at very low temperature. And another reagent we are taking here in this also having one CHO group, means when a carbonyl group is present, so that one will condense with this reactant and we are getting 85% of yield. So this, no need to remember all this reaction, because this kind of question will come in exam. We'll just understand how theoretically we had read there. So how in application point of view or in exam we'll attempt for that. This is one kind of practice. This reactant side, how it is in product, totally same it is written. This is the, with respect to this carbonyl, this is the alpha position and this beta position. This methyl group is the, this methyl group, this is coming towards up, this is beta position. In beta way it is, the orientation only has changed. And from this carbon it is connecting to here, which is OH group is there, that one is forming hydroxyl group, and the rest of part we are just writing similar way. Another example is intermolecular aldol reaction using organocatalyst. In this reaction we are using a organocatalyst, and in the reactant cyclohexanone in presence of which is coming with the parachlorobenzaldehyde in presence of DMSO, 10 equivalent of water at room temperature for 72 hours. For a long period of time this reaction is taking place, which is also giving us the beta hydroxy position of one hydroxy group is coming. This is the alpha and beta, so this is giving us are the required product. So in this way many questions can come in exam. So for that we have to prepare for that only, for your better understanding. I'm just giving different kind of examples so that in exam we will not miss anything. So other than this, with evolution of time, this aldol condensation reaction has used in various cases. Because of that many application it has. So it can be used for the establishment of carbon-carbon bond in gluconeogenesis and photosynthesis, and this is also commonly used for the produce of some solvent like alcohol, isoprene, and diacetone. And in perfume industry, when in industry people are making perfume, in that this aldol condensation reaction involved as an intermediate. And in pharmaceutical industry also, for manufacturing unsaturated ketone and chalcone known as aromatic compound, this thing also can be prepared. Usually it is also used to create plasticizer as well. So many application it carry. For that only with the research, in many research area most of focus is coming to this, and using this aldol condensation reaction many things can be done. So in last, thank you so much for watching this video. Please subscribe this channel so that we'll be in touch with for next video. Thank you.